Let's now solve this exact differential equation. If you are not yet convinced that this is an exact differential equation, please review the previous video as we were able to show already that this is an exact differential equation. And with that, we'll be using the specific steps in solving as exact DE. Of course, we need to start with a review with our m of xy and n of xy because we will be needing them again in this case. So m of xy and n of xy, and if the equation is transformed in this form, will be easily identified. For m of xy here, that's actually the function paired with d of x. So we have this here. That's equal to 5x plus 4y. For our n of xy, that's the function paired with dy. So you will have 4x minus 8y cubed. Okay? The solution for an exact differential equation is in this form: f of xy equal to c. So what we need to do is to reach this type of equation. Hence, let's solve for f of xy. The first process here is solving for a general statement for f of xy, which is actually in this form: the integral of m of xy dx plus a certain function g of y. So once we are done with this, the next thing here is to solve for g of y. Let's plug in first m of xy. You will have 5x, or the quantity 5x plus 4y dx. Okay? And then you will have here plus g of y. Of course, you can always rewrite this as 5x dx plus 4y dx plus g of y, right? Since we are taking the derivative of x, this y here will be taken as a constant. So that would mean, just like this one here, we can take it out, the integral of x dx. And since again y is now considered to be a constant, we can take 4y together. And then you have here dx plus g of y. Okay? So you will have here, of course, 5. Then you have x squared over 2. That's its integral. But of course, in the meantime, let's just not add c. We'll have it later. You will have plus your constant 4y times the integral of dx is actually x plus g of y. So our f of xy is in this form. You can have it 5 halves x squared plus, arranging the coefficients, you have 4xy plus g of y. Okay, now we are done with our first step, f of xy, which is this part here. But this is not yet done because we still have g of y. So let's solve for g of y. We don't want it g of y. We want it really a function of y. So let's solve that first. In solving that, we'll be using this step. We'll be taking the partial derivative of f with respect to y. This would mean this here with respect to y. So you will have the partial derivative of your quantity 5 halves x squared plus 4xy plus your g of y here with respect to y. If it's with respect to an independent variable y, all x's will be constant. This is also x will be constant, so it will be paired with 4. That will be 4x. Okay? So this is actually equal to, so this is a constant that is actually 0. Then you have plus, this will be constant now. Of course, the derivative of y is just 1. So you have 4x. And then plus, you have g prime of y. As of course, we know that to be a function of y. This means that the partial derivative of f with respect to y is equal to 4x plus g prime of y. Okay, 4x plus g prime of y. Next step here, because you would like to solve g of y, not g prime of y, we'll be using this step. The partial derivative of f with respect to y is actually equal to your n of x y, which is already identified earlier. Okay, so 4x minus 8y cubed. So the partial derivative of f with respect to y is this. So copy that. 4x, so let me have some spaces here. You have 4x plus g prime of y is equal to your n of xy, which is 4x minus 8y cubed. So you have 4x minus 8y cubed. We have 4x's on both sides, so you can cancel them. You have g prime of y is equal to minus 8y cubed. Take note, it should be minus 8. Okay, minus 8y cubed. So since we already have g prime of y, and we would like to get g of y here to be paired in this item for our solution, let's integrate both sides. G of y dy is equal to the integral of minus 8y cubed dy. Okay. So of course, this would return to g of y, the thing we're looking for. You can of course leave a minus 8 here if you would like to. Y cubed dy. I'm usually doing that because I'm more comfortable with moving the constant. It will be easier for me to integrate. But of course, if you can, you may not move that out. This is actually y to the power of 4 because plus 1 over 4. Of course, we have plus c supposedly here, but in the meantime, let's just have that. Let's just have only g of y. Okay. So with this g of y, we have 8 divided by 4 is minus 2 y to the power of 4. This is our g of y we needed to complete this function. So our function here again, f of xy is equal to 5 halves x squared. I got that, memorize it, minus plus 4xy. You have plus 4xy plus g of y, right? Supposedly that's g of y, but since you have your g of y already here, x squared plus 4xy, you have minus 2y to the power of 4. We are now done with f of xy. Now, let's just simply write it in this manner as our solution. So the function function f of xy is just equal to c. So this is our f of xy. So this is actually 5 halves x squared plus 4xy plus, sorry, that's minus now, minus 2y to the power of 4 is equal to c. And this is now the final answer to this given differential equation. Okay? So it takes a lot of steps. But actually, if this is non-exact, we still need more steps, and we'll have examples of that later. So we're able to, again, just a summary, go back to this form to identify m and n. You will have your solution at this form. So structure that. You will be getting this function. Solve that using the partial derivative of f, and it's equal to n of xy. Once you integrate it, you will return to your g of y, go back to your function, and equate it to z. That will be our solution now. So this is the solution for this video. But of course, again, this was structured because we already know that this is the exact differential equation from our previous video. So please try reviewing that video on your own time. Thank you very much for watching.